Hello and welcome back to the training. In this video we are going to be getting you set up with your SysTick. Now, as this is the start of what will evolve into our final waveform generator project, we are going to create the start of that project now using the flash LED bare metal as a starting point. So to do that, we're going to right click on here and we're going to copy. And then we're going to right click in the white space here and we're going to paste. It asks us to give us the project name and we're going to call it Waveform Generator. We're not going to use a default location because that will put it in the workspace folder. So we're going to unselect that and we're going to select the folder that is the root of our Git repository that's got our 3 existing projects in it already. We're going to create a new folder in there. And we're going to call this Waveform Generator. Select that folder and copy. And there we have it, our Waveform Generator project, which is set up. Same includes and same source file that we've got already. Here it is. Of course, this is still set up to flash the LED pen, but we can come back to that. One of the key things I wanted to mention in here, we've already seen in the documentation that there's the M4 core, and because we've included all these headers in here, we've got the core cm4.h. There's all sorts of useful things in here, don't worry about it too much, there's lots of crazy stuff in here as well. But down quite near the bottom there is a nice useful little function for us, SystickConfig. Now we're going to use this to configure our system tick. And in here it uses the SysTick control, value and load registers. That's the reload value depending on how many ticks we want. And also, interestingly, there's a -1 in here. And if you think about this, if you wanted to set it to say 10 ticks and you loaded the number 10 in there, the index 0 still counts as a tick, so you'd get 11 ticks. So you really need to subtract 1 from the total number of ticks that you need, because obviously 0 is also a tick. So whatever value of ticks you pass in here, it subtracts 1 from it. Oh, sorry, this -1 here. I was on the wrong line there. This -1 here. This line is setting the priority for the system tick. My apologies, I saw the -1. And yeah, so this is the one where it subtracts 1 from the ticks that I'm talking about here. And this also sets the clock source, tick interrupt and enable, so that we will get interrupts from this. So that's the function that we're going to use. This is the file that we're going to include. Okay, and that will simplify initializing the system tick for us. Now before we do this, what I'd like you to do to make reviewing code changes easier is, once you've copied this waveform generator project into here, come in to your Smart Git and commit the new waveform generator project files. Okay, so what we're going to do is we are going to add a couple of files. We're going to add a SysTick header and a SysTick source file. So to start with, we come up to include here, right click, and we're going to add a new header file. Waveform generator inc, that's the right one, that's the source folder. Header file we're going to call SystickImplementationStart, and we're not going to have a template. The next one we're going to add under our source file, same thing, new source file, and this is going to be systick.c, and again no default, no templates, because we're going to copy that from our main file. Okay, so now we've got main, SysTick, and we've got SysTick header. So if we take our main.c for instance, I'm just going to copy from here all the way down, including the first function header. Go into here, put all that stuff in there, and I can take out the local only definitions so that we just end up with the basic stuff. We still need this include here. The other include that we're going to need is the core mcm4.h file, because that's what we're going to be using in here. We can get rid of everything else apart from the placeholders, and we'll update this in a minute. Also within our systick.header, we're going to want a header. Okay, and another thing that you do pretty standardly in C header files is if you make sure this only gets included once. So you basically say hash if not defined, and this will be systtic header, and then you want to hash define systtic header, and finally hash endif, and then everything in between these 2 points here will be included. The reason I think I need to do something here is we need to go to our main.c, and we need to also include our Systik module. There we go. So I've missed a slash off the end there, which is why this wasn't working properly. Now I've got no errors and no warnings. We have an empty systik.c and an empty systik.h. The other file I'm now going to take you to is you go to your startup folder in here, this file here. You scroll down a little bit, you will find this is some startup stuff which we can go through in mentoring sessions, but it's all pretty standard, you don't need to mess with that. What we're looking for here is the vector table. So this is a table of function pointers, and these are all the possible interrupts that the microprocessor can generate, and they're all defined down here as .weak for each of the handlers. So essentially what that weak means is that we can override any of these with our own function. And up here what we're looking at is quite high up in the list. It is the Systik handler. So this will be a void type function. So I'm just going to copy that, and because it's only been declared as weak, wherever we declare this, it will take effect. So I'm going to pop it in the Systik here, and I'm going to do a void Systik handler void, and there's our Systik function. Okay, so we've now got an interrupt handler routine for Systik. That's good. What we're going to do is we're going to add a local only variable, and I'm going to make this a uint64 type. The reason for that is you can make this a uint32, in which case this is going to be our counter for how many times the system tick interrupt has occurred, and you could make it a 32-bit integer, which will wrap at about 50-60 days from memory. But if you make it an unsigned 64-bit integer, then I think that doesn't wrap for about 3,000 years, and it's nothing to worry about. If you're working on a device or product that won't be left on permanently, so it's only ever switched on for a few minutes at a time, this isn't something you'd need to worry about, but it's a habit I've got into because it can cause you problems when ticks start to wrap, and the amount of time duration that has passed suddenly falls back to near zero. So here we're going to got our variable, and I'm going to call it a UL because it's an unsigned long, and I'm going to call it systik IRQ count. For thoroughness I'm going to set it to 0, but because it's a persistent variable it will be set to 0 at initialization time anyway. I just like to be thorough with these things. So we've got our SysTick increment counter. Each time the SysTick handler is called, I'm going to increment that by 1. So this will count the number of SysTicks that there have been since the system has started. Incidentally, because it's a uint64, so it's a 64-bit integer, and we've got a 32-bit microprocessor, if we used a 32-bit integer here, this would be a single operation within our SysTick handler. So there is an overhead with using a 64-bit integer, because a 32-bit integer would need to use a few operations to actually make that addition, and possibly carry it over into another 32-bit, because it's essentially made of two 32-bit words. So that's our interrupt handler, and that's our variable that is going to get incremented when it gets called. The other thing that we need to do, I do like to be thorough, this doesn't actually have to go in the header because it's been declared weak, the compiler will find it, but I do like to put these in there anyway. And the other one that we're going to have is a SystickInit function, which is also going to be a void. Incidentally, if you hold Control and hit your Tab key, it switches between the header and the source files, which is quite a convenient little shortcut. So now we've got our SystickInit function, and I should also put in here give that a quick header. That should be local only function prototypes. That's something I've missed out, because obviously global function prototypes go in the header file. And this is SystickInit. The only other thing I'm going to put in here under local only definitions is we know we've configured our system clock to be 72 megahertz, so I'm going to put a definition in here of system clock frequency, and I'm going to call that I'll give that the value of 72 million, 72 megahertz, because we're going to be using this in calculations. Incidentally, as the system grows, if we find other things that need to use a system clock frequency, I would take this definition out of here and put it into a global definitions file, so that anything that needed to know about what the system clock has been configured to has the one definition to reference rather than multiple definitions all over the place, which can turn into a bit of a nightmare. So we've got our SystickInit, and we're going to call the function in here, which is SystickConfig. If we're going to call that, we've got the include up here. If you forget that, it won't work. So we're going to initialize to our system clock frequency divided by 1000. So that's how many clock cycles there'll be per second. So divide that down by 1000, that should give us a SysTick handler call once every thousandth of a millisecond, which is once every millisecond. So that's our SysTick initialize function, and the last thing we need to do is in our main function, we've got our micro initialization. So in here we initialize the external clock, and before we initialize the GPIO, we can put it in there. Initialize the SysTick interrupt. Give that a quick compile. I've obviously messed some things up somewhere. Hopefully that's all it is. That looks good. So now if we run this, one of the things I'm going to do is I'm just going to copy that, because there's a useful feature. So we're going to run this, debug as STM application. That's all standard. let me connect up my kit. Bear with me for a second. Okay, let's try that again. Now that's up and running, we're ready to do our micro initialization. We can run this. We can come over here to live expressions, and if you paste your ULL Systic IRQ count in there and hit return, you can see that's counting up in milliseconds. Obviously this doesn't update every millisecond, it's just a few times a second, but you can see those two digits there are counting up in a 1 second rate with millisecond resolution on it. So there we have our Systic interrupt running. If you've had any problems getting that running, please do give me a shout and we can work through that. And what we're going to do in the next video is add some helper functions that will allow us to utilize the Systic to be able to time things, and we're going to change our main loop here so that we're going to be toggling this LED on and off once a second as timed by our Systic interrupt. So, I hope you've enjoyed that video. I hope you've got that all working. If not, give me a shout and I'll see you in the next video. Bye for now.